So in this video, I'm going to go over the Mach 11 review. So our first question here says a scientist collects a bacteria sample that begins with 5 million microbes. The sample triples in number of microbes every 20 minutes. The sample can be represented by the exponential equation y equals 5 times 3 to the t over 20. Which of the following represents the equation solved for t? So what we want to do with this one is we want to get everything but t to one side. So first of all, I'm going to rewrite the equation. Okay, so the very first thing I'm going to do is I'm going to divide by that t, or the 5, sorry, because I want to get, again, the t by itself. So I'm going to divide by 5. So it's going to give me y over 5 is equal to 3 to the t over 20. Now, we're going to write this in log form. Okay, so we got our base. That's our 3. So we're going to say log base 3 of what's on the other side of the equals. I remember these things are going to now switch sides, okay? So that's going to be y over 5. And that's going to be equal to t over 20. Now, how do we get rid of something that's in the denominator? We multiply by it, right? So this is going to be 20 times t. So this will be 20 times log base 3, because now that's gone. So our answer would be t is equal to 20 log base 3 of y divided by 5. So which one of those was the answer? Here, let me erase this because I don't remember where the answer was. So 20 times log base 3. Well, first of all, let's look at this too. That's definitely not going to be your answer because that's not y divided by 5. That's not going to be your answer because that's not y divided by 5. So 20 times log base 3, y divided by 5. That's our answer. So our next one's number 2. So it says which expression is equivalent to y equals c times log base 4 of ab plus 10. So what's our first step here? So remember, times is more like it's attached to that, right? Because it could be c and then just the next thing, right? Okay. So when we do this, we're always going to do what's outside of there. So we're going to subtract this 10 because it's not actually attached to the log base 4ab. Okay, so it's y minus 10 equals c times, again, log base 4 of ab. Now we're going to divide by that c. Okay, we're going to keep working. So now we have log base 4 of ab is equal to y minus 10 over c. Now we're going to change it into an exponential. Okay, I'm going to go over here to the right. So we're going to say 4 to the, what's on the other side? Remember, these two are going to switch sides now. Okay, so 4 to the y minus 10 over c power is equal to a times b. Then our last step would be to divide by a because we're solving for b. So we're dividing by a here. So our answer would have been b right there. So the next one says expand the logarithm, okay? So this time, we're going to simplify first. That always should be your first step here, guys. So we got log base 4 of. We don't have another coefficient, so we can't reduce the 3, so we're going to leave the 3 up top. We don't have another x, so we're going to leave the x up on top. Then we have y to the 5 minus 8, and that would be y to the negative 3, so that means that y to the third is going on the bottom. And what I told my guys is always subtract, and wherever the bigger number is, that's where your result's going to go. Okay, so now we're going to write this as a log base 4, and this is going to be 3. And that's because it's positive because it's on top, and then plus log base 4 of x, again positive because it's on top, and then minus log base 4 of y to the third. Now that third power, that doesn't really look like a power, so don't make me look like a power. That's going to go out front, right? So our final answer is going to be log base 4 of 3 plus log base 4 of x minus 3 log base 4 of y. So our answer on this one is D. All right, so the next one says write 3 ways to expand the logarithm, okay? So the first thing I'm going to do is I'm going to apply this to both of those terms, right? So when I do that, I'm going to get log base 7 of 3 to the 4th times x to the 4th, right? So hopefully you remember that when we do this, those coefficients are going out front. So one way to rewrite this is log base 7 of 3, and then we're going to put that 4 out front, plus log base 7 of x, and again, we're putting the 4 out front. So that's one way to write it. Now, another way to write it is to leave this a number, right? So that could be log base 7 of 3 to the 4th, which is 81. And that's plus 4 log base 7 of x, right? Now, there's one more way we could write it. Actually, there's a couple more ways we could write it because we could have combinations of things. But let me show you the third distinct way to write it would be to write our log base. Because there's 4 here and there's 4 here, we could write log base 3 4 times. We could write log base 7 of x 4 times. So we could say log base 7 of 3 plus 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 4 of our log base 7s of x. Okay, so there's our 3 distinct ways. 1, 2, 3, and obviously you could have combinations of both of them. All right, so for number 5, it says solve for x. So here again, we have 18 plus 6 ln 3x minus 5 equals 30. So anytime we have a plus or minus, we're going to deal with that first, okay? So we're going to deal with this 18 first. So we're going to subtract 18 from both sides. So that's going to give us 6 ln of 3x minus 5. That equals 12. Now we're going to divide by that 6, okay? Because remember, we got to get ln by itself, okay? So now we have ln of 3x minus 5 is equal to 2. So how do we get rid of an ln? We take it to the e power, right? So we're going to do, and then when we do that, this now cancels out. So now what we have is our 3x minus 5. And then when we do e to the second, we get 7.389. We're going to add 5 to both sides. So that's going to be 3x is equal to 12.389. Then we're just going to divide both sides by 3. And so when we do that, we get 4.130. And I checked this. I went ahead and plugged it back up in there and made sure that when I did all of this left side, it equaled 30, and it did. Okay, so your answer was x equals 4.130. So for number 6, this is e to the 5x plus 4 equals 8. Now, once again, we're going to move that 4 first. We're going to subtract 4 from both sides. So now we get e to the 5x is equal to 4. How do we get rid of an e? We do the inverse, which is ln. So we're going to have ln of 4. Here again, these two cancel each other out. So we're left with 5x equals whatever the ln of 4 is. And the ln of 4 was, what did I get here? 1.386, and then we're going to divide that by 5 on both sides. So x is equal to 0.277. And again, you can check that by taking 5 times 0.277 to the e power, right? And then adding 4 to that, and that should give you 8. So number 7 says which function represents the inverse. So remember, with inverses, we're swapping our x and y. So we're going to put x where our y was. And so we have now log base, where we have log 2 of y minus 15. So here again, all of that log base is connected. So we're going to add 15 to both sides. So this is x plus 15 equals log of 2y. I don't know why I put a parenthesis up there, y'all. So at this point, we're going to put it in exponential form, okay? So remember, when there is no base, the base is 10. So we're going to take our base, 10, and we're going to switch these two things again. So this is going to be to the x plus 15 power, and that's going to be equal to our 2y. So to solve for y, our last step would be to divide by 2, wouldn't it? So that means y is equal to 10 to the x plus 15 power, all divided by 2. So it looks like that answer is D. All right, let's do number 8 and 9. All right, so with 8, can't quite see that, y'all, so let me move this. So here, there's actually a couple ways we could do this problem. So I'm going to show you both. So first of all, let's let's write it as a log. So log base 4 of what's on the other side of the equal sign is 64. That's going to be equal to our 2x plus 5. So this next step, we could do it one of two ways. We could say log base 4 of 4 to the third, and when we do that, we know what? Those two cancel each other out, so we get a 3. Or let me show you the other way, and I'm just going to leave this 25 over, or 2x plus 5 over there, and I'm going to show you the other way to do this, okay? So you could also do log base 4, log base, so the way it's written, we could use the change of base formula, okay? So log of 64 divided by the log of 4, and we would still get that 3, okay? So that means that's still going to be equal to our 2x plus 5. So we're going to subtract 5 from both sides. That's going to give us a negative 2 is equal to 2x. So x is equal to negative 1. And again, you can throw it up there and check it. So if we do 2 times negative 1, that would be negative 2 plus 5 would be 3, and 4 to the third is 64. All right, let's look at number 9. This one says, solve for x again, log base 6 of x minus 7 equals 2. So we're going to just write this in exponential form. So this is going to be 6 to the second equals x minus 7. Remember, we keep our base and we switch sides with the other two things. This is 36 equals x minus 7. So we're going to add 7 to both sides. So that's 42. Right? No, 43, sorry. 43 equals x. Okay? And make sure you check these, okay? So when you plug them back up in here, 43 minus 7 is a positive number, so make sure you are checking those, okay? When you are solving, that's key. So number 10 says solve for x. When we have log base 3, we're going to condense this first. So our first step is going to be to condense. Our second step is going to be to cancel the log base 3. Okay, so let's go ahead and do that. So our first step is going to be log base 3 of 5 times 6x plus 3. And the reason why it's times is because there's a plus sign right there. If there was a minus sign there, we would be dividing, okay? That's equal to, and we're going to go ahead and condense this as well. So this is log base 3 of 2 to the 4th. So now our next step, we're going to have to actually cancel out our log bases and do our multiplication in the same step, okay? So 5 times 6x is 30x. 5 times 3 is 15. And this is equal to 16 because 2 to the 4th is 16. So then we're going to subtract the 15 from both sides. So that's going to give us 30x equals 1, and then we're going to divide both sides by 30. So it's going to give us 1 over 30, and if we look at that as a decimal, it's going to be 0.033, okay? Now again, check it up here. So that would be 6 divided by 30, which would be 1/5. That's still going to be positive, so that's what you're looking for, okay? So on the next one, it says which statement describes the end behavior. So we're going to look at this in decimals. So I'm going to go up here and I'm going to do 2e. Now recall, anytime you have more than one value up here for an exponent, when we do our shift 6 to do our caret symbol, we're going to put a parenthesis, okay? Because otherwise it's only going to give us one value up there. So we got to put a parenthesis up there. So this is going to be x plus 4. Close our parenthesis. Then we're going to go back down and do our minus 6. So now, when we look at this, this is asking us about end behavior. So let's go ahead and write what's happening here. As x approaches infinity, f of x is approaching infinity, isn't it? Because it's going up, okay? Now, the difference is here when we go as x approaches negative infinity, what's happening to our f of x, guys, this time? It's approaching that horizontal asymptote, right? So this is approaching negative 6. So that's our key there, okay? So now let's go back and look at it in on our... So as x approaches infinity, f of x approaches infinity, that's true. This would not be true. That would not be true because we're not approaching 1. And as x values approach negative infinity, the f of x values approach negative infinity. That's not true, but there's our -6. So there's our answer, okay? So I would go ahead and write down what the actual end behaviors are if I was doing an end behaviors problem like this, and then just compare the answer choices with what I have. The next one says the population of a local town is currently 25,000 people. So that's going to be our P. And then it says if the population drops, so that means we know it's going to be a minus. So but let me just say our formula here. So our final amount is equal to our principal times 1 minus r to the t power, right? So those are the variables we're looking for. So this is our rate of interest. Remember, we're going to have to move this 2 places to the left. So it's going to end up being 0.0102. And then this is our final amount because it says which of the following equations represents how to find the number of years it will take for the population to reach 20,000. So it means we got 20,000 over here is equal to our 25,000, 1 minus 0.0102 to the t power. So that's our formula right there. All right, the next one, 13, says which statement is false about the graph. So I like to write my domain and my range, my end behaviors, all that stuff on here so I can then just compare what I have. So based on this graph, our domain is limited, right, because we have a vertical asymptote of 2. So this is going to go from -2 to infinity. And is the graph decreasing or increasing? It's increasing. So we're going to write that because the interval of increase has to do with our domain, right? Then our range is going to be all real numbers, right? Because the graph is going down and it's continuing to go up. So that's going to be from negative infinity to infinity. And then it doesn't say anything here about an asymptote, so I'm not going to worry about that right now. But our asymptote is x equals 2. And then let's talk about our end behaviors. As x goes right, y'all, towards infinity. This is infinity, right? Where's our f of x going? F of x is approaching infinity, right? Now, as I head left, I'm going to say as x approaches R2, what happens to our f of x? Because remember, we can't go past that asymptote. Here, it's headed towards negative infinity, right? So now let's just check what we have. So as x heads towards 2, does our graph head towards negative infinity? That is true. And by the way, we're looking for a false answer up here. The range is from negative infinity to infinity. That's also true. The interval of increase. There's our problem. It's from -2 to infinity. So that's actually our answer right there. Because it is not true. And then as x approaches infinity, f of x approaches infinity. So I always like to do domain, range, and end behaviors and intervals and all that stuff just to double check stuff. Okay, so number 14 says which statement is true about the graph. Okay, so here again we have, this time we have a horizontal asymptote, right? So that's going to be at y equals, what is that? Zero's down there, so that's what, 1? Okay. So again, let's talk about domain. So our domain, is it limited at all? No, because it's going left and right. So it's from negative infinity to infinity. What about our range? This is going to be limited, right? So where does our graph start? It starts at 1 and it goes on to infinity, right? Now let's talk about our domain with respect to decreasing or increasing. This graph is increasing, right? Because it's rising from left to right. Okay, now let's talk about our end behavior. As x approaches infinity, going right here, where's f of x going? F of x is also going towards infinity, isn't it? Then as we go left, as x approaches negative infinity, what's the graph approaching? F of x is approaching that 1. Okay, so now we're just comparing again the statements down here with what we did. As x approaches negative infinity, that's this statement right here. F of x approaches 1. So this one says which statement is true. That's our true statement right there, right out the gate. But let's double check the rest of them. F of x is a vertical asymptote. No, that's a horizontal line. So that's not true. And it's not even x equals 2. So that's all false. The range is from 1 to infinity. So that should be a 1 right there. So that's also false. And then as x approaches infinity, f of x is going towards infinity, isn't it? So that's also not true. All right, so on which interval are the values of the function graphed below positive? Okay, so right there is where the graph transitions from being positive to negative. So if this is positive, we're looking for something that's over here, guys, okay? So we want to look at something from negative infinity to negative 5, right? That's where we're looking for, our numbers that are positive, okay? So any group of numbers that's within that frame. So negative 3 is over here. So that's definitely not one of them. B is negative 5 to negative 3. So negative 5 to negative 3. No, that one crosses. Okay, so that's not it. That's not it. Negative 6 to negative 4. It also crosses in that one. So then we've got negative 8, which is out there somewhere, to negative 6, right? So that's our answer right there. Okay. All right, so 16 says which statement's false about the graph of the square root. So this is another false statement. So again, we're going to talk about our domain. So our domain starts at negative 2 and it goes on to what? Infinity, because it's going to the right. Our range starts where? At 0. Well, actually, it starts at negative infinity and goes up to 0, doesn't it? Okay. So this should be a bracket, y'all, and that should be a bracket. All right, so is this graph increasing or decreasing? It's decreasing, so I'm going to write decrease. That's our interval, right, on our domain. And then let's talk about our end behaviors. As x approaches the right, which is infinity, what's happening to our f of x? It's going down, isn't it, y'all, right here? See that? So that's going to negative infinity. Then as x approaches negative infinity, what happens to our f of x? Doesn't it stop, y'all? Where does it stop? Right there. At what? Approaches 0. Okay? So now let's just check these and see if they're right. So our first one's an end behavior. So as we go to negative infinity, f of x approaches negative infinity. So the answer to that one is true, and we're looking for a false answer. The range is from 0 to negative infinity. No, we had the range was from negative infinity to 0. And this has positive infinity. So that is our false answer, right? Which would be our answer. And then the interval of decrease from negative, that's our domain. That's true. And it is decreasing. And then as we go right on the graph, our graph is headed towards negative infinity. So that is also true. Okay. So there we go. So number 17 says find the inverse of this function. So the first thing we're going to do is swap x and y. X equals 9 to the 7th root of 2y minus 5. So remember, we're going to do anything outside that radical first. So we're going to divide both sides by 9. So it gives us x over 9 equals the 7th root of 2y minus 5. How do we get rid of a 7th root? We take it to the 7th power, right? So that gets us x over 9 to the 7th power equals 2y minus 5. Again, going to add 5 to both sides. So we're going to add 5 here. We're going to add 5 there. So now we have x over 9 to the 7th power plus 5 is equal to 2y. So our last step would be to divide by 2, right? It would be, yep. So that's our answer for the inverse, okay? X over 9 to the 7th power plus 5 over 2. All right, so the next one says which function represents the inverse of negative 3/4 x minus 12. Now, I emphasize this a lot with my class. If the slope is negative, it's going to stay negative because we got to get a value here that's a positive 1. Okay, so the very first thing I'm going to do again is swap my x and y. So I'm going to say x equals negative 3/4 y minus 12. So we're going to add 12 to both sides. So it's going to give me x plus 12 equals negative 3/4 y. Now, how do we get rid of a negative 3/4? We multiply by same sign, but we then the reciprocal. So it's going to be negative 4/3, okay? And we're going to multiply both sides times negative 4/3. And y'all, please do this in your calculator because it does all the work for you. So negative 4/3 x, and a negative times a positive is a negative. And if we multiply negative 4 times 12, we get negative 48. Negative 48 divided by 3 is negative 16. And again, just multiply this. Remember, you got to distribute this to both numbers. And when you do negative 4/3 of 12. In the calculator, you get negative 16. And that takes no thought at all. Just do it in the calculator. So which one of these matches our answer? We got, it's not that one because that's a negative 3/4. Okay. All the others are negative 4/3. But which one has a negative 16? It's this one right here. Okay. So 19. This one, we're going to convert these to fractional exponents first. Okay. So this is going to be 18x of 18 divided by 9, and this is going to be x of 9 divided by 3. Now, I want to remind you guys, anytime there's not an index, the index is 2, okay? That means the root, okay? So 18 divided by 9 is 2, and this is 9 divided by 3 is 3. Now, anything we have in the denominator, we're going to subtract, right? So we're going to do x2 minus 3. So that's going to be x to the negative 1, which is 1 over x, okay? The next one we're going to simplify. Okay, so here again, I'm going to look for my like terms. So there's my a and my a. So I'm going to do a to the 6, and I'm going to subtract what was in the bottom. That's minus of minus 1/3, right? So that's going to end up being plus. And then we got b to the 2/7 minus again a minus 4/7. So recall again that when we subtract a negative, it becomes a positive, right? So we're going to add those. So this is going to be a to the 6. Again, do this in your calculator, guys, so you can see the different answers. So 6 and 1/3, if I put that in fraction form, if I add 6 to 1/3 in my calculator, I get 19 over 3, okay? And then with b, this is going to be b 2 plus 4 is 6, so this is going to be 6/7, okay? And by the way, if we wanted to put this back in exponential, in a radical form, we would say a to the 3 is the index, right? And then this is 19 times, again, b is here, our index is our denominator, and our 6 goes there, okay? Just so you guys can see it. All right, here are our stat questions. This is our new content. So it says scores on the midterm were normally distributed with a mean of 65, a standard deviation of 8, using the empirical rule. Okay, so really key here, guys. When it says this, you want to create your curve, okay? So that's what we're going to do. So we're going to put our 65 here, and we're going to go 1, 2, 3 to the left, and we're going to go 1, 2, 3 to the right, okay? So when we do that, we add 8, we get 73, and then we get 81, and then we get 89 here. And when we go left, we're subtracting. So we get 57, 49, and 41. Okay, now remember, on your formula sheet, you have these percentages. This is 34, this is 34, and the formula sheet will be on the test. This is going to be 13.5 and 13.5, 2.35 and 0.15. Be great if I could write, y'all. Just can't write today. Let me move that out of the way first. This is 0.15 out here. This is 0.15 out here. And this is 2.35, okay? These are percentages, because when you add all those up, you get 100, okay? Let me pull this curve out here a little more, okay? So now, we're going to see what it says here for each of these problems. Less than or equal to 73. So when it says less than or equal to 73, there's my 73. If it says less than, I'm going left. So that means I'm going to add up all those percentages. So I'm going to show you guys a really easy way. Half of your, this is half, right? So that's 50. And we're just going to add that 34 to it. So when we add 50 to 34, that's going to be equal to 84%, right? Or 0.84. Okay, now listen. If that doesn't work for you, then you add up the 0.15, the 2.35, the 13.5, the 34, and the 34. You're still going to get 84, okay? Now the next one is greater than or equal to 81. So that's right here, okay? So that means we're going this way now, right? So we're going to add 2.35 plus 0.15, and that's going to be 2.5% again, or 0.025. This one would have been also equal to 0.84, okay? Now the last one we're going to do is between. Okay, so we're going to go between 57 and 73 right there, okay? So between 57 and 73, we're just going to add those two together. 34 and 34 is 68, right? So that's 68%, which is equal to 0.68, okay? So now, I want you guys to recall, I'm going to go ahead and rewrite these. So right here, these 2%, one standard deviation away is always 68%. 2 standard deviations away is always 95%. 3 standard deviations away is always 99.7%. So this says, what are the two values that the 99.7% of the data falls between, right? So in this case, we're looking at our last numbers, right? So we're going to say that this is between 41 to 89, because there's our 41 and there's our 89, okay? Now, the next one says an annual rainfall in an Alaskan town is normally distributed with a mean of 150 inches per year and a standard deviation of 36 inches per year. What is the probability that the rainfall is? Okay, now this does not say to use the empirical rule. So this is the one we can use our calculators for. So this is when we're going to do second VARS, and then we're going to choose number 2. Remember, we're going to do a lower bound, an upper bound, and then we're going to do our mean, and we're going to do our standard deviation, okay? So lower bound, upper bound are going to change for this problem based on A, B, and C, but mean and standard deviation are going to stay the same. So the annual rainfall is distributed with a normal mean of what? 150. So that's going to be right there. And then the standard deviation is going to be 36. Those measures are going to stay the same for all our problems. So what I like to do when it has a problem like this is I go ahead and draw my curve, right? So then it says at least 190. So 190 is there, at least means it's going that way. So anytime we have a problem like this, our upper bound is going to be 1,000,000, right? A really big number. Our lower bound, if the arrow is pointed left, it's going to be negative 1,000,000, okay? So this time our lower bound is going to be our what? 190, and our upper bound is going to be our 1,000,000, okay? So this is for A. So let's go ahead and do that in the calculator. So here's our TI-84. So I'm going to go second VARS right there and choose my number 2, normal CDF. So you can either scroll down or click 2 and enter. Okay, now notice we have here our lower, upper, mu, and standard deviation. So what we're going to do is put 190 in here for our lower bound and enter. Then for our upper bound, we're going to put 1,000,000, a really big number. Okay. Then we're going to put our 150 for our mean. And then we're going to put 36 for our standard deviation, okay? We're going to click enter again, check our numbers right here, and then we're going to click enter again. Now, if you have an old TI-84, these, you're going to always put it in this way, LUMS, okay? So I just would memorize that, LUMS, okay? So click that, and there's your probability. It's going to be 13.32% or 0.1333, okay, and it could be written either way. So let's go ahead and pop out of that. So this first one is going to be 0.1333, which is equal to 13.33%, okay? So B says no more than 100 inches. So this one I'm going to actually draw our curve again, and our 100 inches would be there. And this says no more than, so that means we're going this way. So that means our left bound this time is going to be a very small number. So our left bound is going to be like negative 1,000,000, right? That's a really small number. And our upper bound this time is going to be what's on the right. So what I always do is I put them on a graph like this, then I know the smaller number is going to be our left bound, and the larger number is going to be our upper bound. And if I have an arrow, then I'm going to have a really big number or a really, really small number, okay? So our upper bound here is going to be 100. So let's go back and put this in the calculator again. So we're going to go back to second VARS, down to normal CDF, enter. So our values here, this time is a negative 1,000,000 and 100, 150 and 36. So we're going to click enter, enter, enter. I already put them in there. You guys can tell. Whoops, what happened? Second VARS to enter, 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 click. I don't know what it's doing, y'all. Second mode. Let's just clear the thing out. Second plus 7, 1, 2, and we'll start over. So we're going second VARS again to number 2, enter. So that's going to be, let's go back up here and put negative or yeah, negative 1 million. Make sure you do a negative and not a minus, yeah, okay? Because you will get an error message. Our upper boundary was 100. Our mu was 150, and our standard deviation was 36, right? Okay, so we're going to put enter, enter, enter. There we go. So this one's 0.0824. So that's what we're going to put for this one, 0.0824, which is equal to 8.24%. All right, so our last one is our C, and this one's a between. So when we have, again, a between, then we've got our 100 here, and we got our 200 here. And remember, I said whatever's on the left is going to, or the smaller number is going to be your lower bound. So our lower bound is going to be 100. Our upper bound is going to be 200. So let's again go back to our calculator. So we're going back second, vars, and again, those values should already be in there, guys, for the mu and the standard deviation. So all we're now putting in here is our lower bound and upper bound. So we're going to put 100 here, and we're going to put 200 there. Keep clicking enter till you see it, and then it's going to be 8.8351, right? So 0.8351 is the answer to this one. 0.8351, which is 83.51%. Okay, so got a couple more. It says below is a chart of tips for 2 waiters per night for 5 nights. Find and compare the mean and standard deviation for each. So what we're going to do is we're going to put all these values in there. We're going to find the mean and standard deviation, the mean and standard deviation here. Okay, so we're going to go back to our calculator. So now I'm just going to stat, and we're going to go to edit, because that's where our L1 is. And we're going to put these values in. So you're going to put 135, 220, 255, 195, and 310. And then we're going to go back to second. No, actually, sorry. We're going to go to stat again. Not second stat, but just stat. And over to calc. Click calc. And then we're going to go to one variable stats, okay? So you might want to write that down on your paper just to memorize it, okay? So here we're looking for our mean, which is the x with the line over it, and we're looking for our sigma, which is 58.53, okay? So we're going to put those back on here as our mean and our standard deviation. So our mean was, for this set of numbers, was 223. Our standard deviation was 58.53. Then we're going to go back, and we're going to do the same thing for the other set of numbers. So we're going to go to stat again, push enter, and we're going to actually go up to the top here, and I'm going to clear this out. So I'm just going to click clear, enter, and then I'm going to put my other data in there, 125, 240, 250, 185, and 360. Okay, and once again, I'm going to click stat, go over to calc, one variable stats, click enter, 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 till they give them to me. So now we have our standard deviation is 232. Our mean is 232, and our standard deviation is 78.013, okay? Or just 03, you can notice that, 78.01, okay? So we're going to go back here, and we're going to write that again. So here, our mean now is 232, and our standard deviation was 78.01, okay? So now let's look at these statements. The mean is lower for waiter 2. That was not true, so that's not the answer. The mean is higher for waiter 2. It is higher, but the standard deviation is lower. That's not true. So the mean and standard deviation are lower for waiter 2. That's definitely not true. So the mean and the standard deviation are lower for waiter 1. That is true. So our answer was D. So just check through each one of them based on your information. So last one here, the following data values represent test scores. So we're going to put these in our calculator, and we're going to find out what the mean and standard deviation is, Q1, Q2, Q3. So here again, we're going to go to stat. We're going to enter this data into our calculator. So I'm going to go back up here and clear this out again. So I'm going to click clear, enter. Then I'm going to put these values in. So I'm putting in 80, 72, 80, 68, 75, 94, 78, 86, 75, and 64. Okay, so let's go back here to stat and over to calc. So we're going to pull several data points here, okay? So we're going to pull the mean and the standard deviation. We're going to pull Q1 and Q3, okay? So we're going to have to scroll down to see Q3. There it is. So we're going to pull mean, standard deviation, Q1, Q3, okay? Mean was 77.2. And by the way, always check this in to make sure that you have a number of points in there that you think you should have. Our standard deviation is right here. That's going to be 8.195. Q1 is 72. And Q3 is 80, okay? So we're going to go back here and enter that data right here so we have it written down. So we have our mean, which we could do this way, or X with a line over it. Doesn't really matter which one you do, but it was 77.2. That's for our original data. Our standard deviation was 8.195. We also need our Q1, which was 72. We need our Q3. That's 80. We're going to subtract those to get our IQR, remember. So we're going to subtract Q3. We're going to subtract Q1 from Q3, so that's going to be 80 minus 72. That's going to give us 8. Okay, now the way we find our outlier is we can find a lower bound. I want to actually write that out. Lower bound. And to do that, we're going to take our Q1 and we're going to subtract from it 1.5 times our IQR. Okay, so that's going to be equal to the 72 minus 1.5 times what? Our 8, right? So when we do that, now remember, you should multiply the 1.5 times the 8 first. When you multiply 1.5 times 8, you get 12, right? So that's going to be 72 minus 12. That means it's going to be 60. That's going to be, any number below that is going to be out of our bounds, right? Then we got our upper bound. And to do this one, so this one's going to be Q3 plus our 1.5 times our IQR, okay? So that's going to be equal to our 80 plus our 12. We don't have to compute the IQR twice because we know what it was. It's right here. So that's going to give us 92. So then we're looking for any numbers that are above our 92, right? So now let's look up here at our numbers, okay? So we've got 80, 72, 80, 70, yeah, 68. Oh, look at 94. That's above our 92. So I'm thinking that's our outlier. It is our outlier, actually, guys. So our outlier is 94. Now, to figure out how it affects the mean and standard deviation, we got to take it out. So let's go back and take it out of our data. So we're going to click on Stat here again. We're going to go to our list, and we're just going to scroll down to where that 94 is. We're going to click Delete, and then we're going to go to Stat again and over to Calc again and compute our one variable stats here, number 1. Click, click, click. And notice now we have a new mean and a new standard deviation. So that's what we're going to write down. 75.33 and 6.31. So our new mean, so I'm going to write it in different color green. Our new mean, which is our X with the line over it, was equal to 75.33. And our new standard deviation was 6.307. So what we want to do now is compare them, okay? So we're going to compare our means, which our mean of our new, with the with the outlier taken out, is higher, or lower. So, and what about our standard deviation? It's also lower. So when we talk about this, it really depends on how the question is worded. If we have answer choices, okay? So this time I'm going to state this a little bit different than we did in our notes before. So we're going to say, when the outlier's removed, both the mean and the standard deviation are lower, right? Now you could say the converse, right? You could say if it was left in the data, both the mean and the standard deviation were higher, okay?